Hi, I'm Vincent Viviana, and this is my video journal for the forensics module in the SMT program. And this lecture covers how investigators collect and analyze digital evidence, but the part I want to focus on today is how memory forensics help reconstruct an attack using the real-world SolarWinds SUNBURST incident as an example. From the lecture, I covered digital evidence principle, FAT and NTFS file systems, images, and document forensics, mobile forensics, network forensics, and also memory forensics. Out of all of that, memory forensics stood out to me the most because it deals with evidence that can disappear the moment a system shuts down. Digital evidence falls into two categories. A persistent evidence like this file and logs can remain even after a shutdown, but a volatile evidence, things like running processes, network connections, and credentials in memory, can vanish the moment the system powers off. That's why some of the most valuable evidence only exists while a system is actually running. So, what can memory actually reveal? Four big things, which is processes, modules, connections, and credentials. This matters because memory forensics can expose attack activity that wouldn't show up on this evidence alone, which makes it critical for catching stealthy advanced attacks. To make this concrete, I'll look at the SolarWinds SUNBURST attack from 2020. It started with SolarWinds Orient software was compromised, allowing attackers to distribute a malicious update. Once that update executed, the SUNBURST backdoor activated, compromising a victim system and giving attackers persistent access. What makes this attack so dangerous is that it came through a trusted software update, the entry point for a massive supply chain attack. So, how would forensics actually reconstruct something like this? It follows a chain start with the compromised system, collect digital evidence, analyze runtime activity in memory, correlate that with other evidence, and then reconstruct the attack timeline. In short, host, then memory, then processes and connections, then this and network until you can finally answer the question what actually happened. Memory, disk, and network evidence each reveal a different piece of the puzzle. And so the biggest takeaway for me is that an attack might disappear the moment a system shuts down, but the right evidence, especially volatile evidence captured before that happens, can reconstruct its entire story. That's why promptness and proper collection order matter so much in real investigation, not just in theory. That's it for this journal. Thank you for watching.